Hello, everyone. Welcome back to the seminar. So I'm very happy to introduce you, Paul Dumouchel, that we all know because Paul is a researcher with us at the ACT project, and I think, not I think, but he's part of the sub-project 13.
13, yeah.
Under the guidance of Jackie Burkle. Paul is a professor of philosophy at Ritsu Meikan University in Japan, but I know that he is in Quebec, still stuck in Quebec.
Unable to go back to Japan.
So meanwhile, let's stay virtual, and we are leaving you the floor, my dear Paul, for your presentation.
Okay, thank you. So good morning, everybody. Thank you for inviting me to give this talk. The goal of this paper is really to compare intelligence, artificial and otherwise, in other words, artificial and human intelligence, but to compare it in a more detailed way, in a sense, than the way in which it is usually done, which is simply to evaluate how machines are brighter than us or not. So what I want to do is to compare this, taking into account three factors, one of which is forms of embodiment. The ways in which artificial intelligence and human intelligence are embodied, I think, plays an important role in the difference between them. The other one is autonomy. And the last one, which should be of interest of this group to some extent, is the question of judgment. So overall, I will simply read this paper. So human intelligence, what is artificial intelligence? Human intelligence is notoriously hard to define. What does it mean to say that an answer is intelligent or that a person is brilliant, apart from the fact that the answer is unexpected and striking, or that the person who found it had access to only a small part of the relevant information? Intelligence seems to fall within the category of those things of which we say, I can recognize when I see it, but I would not be able to define it. Perhaps as an attempt to overcome this difficulty, psychologists have devised many tests that aim at measuring intelligence. However, it is not entirely clear what these tests measure. They have often been accused of bias, of favoring or discriminating against different racial and cultural groups, against women, against those who are handicapped. Over many years, the highly polemical debates surrounding this have resulted in the proliferation of such tests, with different ones aiming to measure different forms of aspect of intelligence. In every case, what these tests target are various abilities, including the ability to reason, to understand, to store information, to analyze, to synthesize, to revise, to retrieve information, and to process auditory or visual stimuli. They measure the speed of processing and decision time, reading and writing ability, quantitative reasoning, and the short and long-term memory. Intelligence, so conceived, would appear to be reducible to a collection of loosely related cognitive abilities, yet the tests are such that together they yield a unique measure, the IQ level, and that's the point which I think is important, which is viewed as being related to certain types of behavior or conductive to particular values and social ends. For example, variance in IQ is correlated with, among other things, job performance, academic success, criminality, juvenile delinquency, teenage pregnancy, and so on. Intelligence, as the term intelligence, as applied to human them, is certainly not a well-defined term. It does not correspond to a single unified capacity or faculty. Rather, it refers to a cluster of different abilities that are deemed necessary to achieve some desired objective, like academic or economic success. However, because we, as individual human beings, are the bearers of this intelligence, and because intelligent tests yield a single measure, it is nonetheless commonly thought of as just one single coherent ability. Furthermore, because the test provides a unique scale on which to compare different individuals as more or less intelligent, they encourage us to think that intelligence is itself something, a property that exists in itself, independently of the individual who manifests intelligent behavior. A somewhat similar, but nevertheless different situation arises in the case of AI. One generally recognized difficulty within the field is the presence and persistence of disagreement over what could count as a precise definition of artificial intelligence. The common solution to this is to adopt a broad-ranging, highly inclusive definition. For example, the 100-year study of artificial intelligence project at Stanford University characterized AI as a set of computational technologies that are inspired by, but typically operate quite differently from, the way people use their nervous system to sense, learn, reason, and take action. This lack of precision is actually in keeping with the original project of artificial intelligence. When McCarthy, Minsky, Rochester, and Shannon introduced the term and proposed it as a new domain of inquiry, their goal was to explore what intelligence is by reproducing it with the help of computers, its various aspects such as reasoning, perception, calculation, and memory. They took as a methodological standing point the idea that every aspect of learning or of any other characteristic of intelligence can be described so precisely that it becomes possible to build a machine able to simulate it. It is therefore hardly surprising that what today constitutes artificial intelligence is in fact a disparate and loosely connected set of computation-based technologies that try to imitate or to reproduce or are modeled on various abilities that are typically associated with human intelligence. Yet, as in the case of human intelligence itself, people tend to construe artificial intelligence as something that is simple and unified. Even so, instead of a particularly faculty or ability, and perhaps because the bearers of that intelligence are not in this case clearly recognizable individuals, they often view artificial intelligence as a special entity, something that exists in itself, AI, since they also consider that intelligence can be measured on a unique scale, allowing us to compare and rate as more or less intelligent different bearers of intelligence, whether they be human or artificial. They conclude that it makes sense to compare and measure the relative dimension, force, or power of human intelligence and artificial intelligence. Artificial intelligence, then, is like human intelligence, is not a well-defined category. It does not correspond to a single faculty, but to a collection of computational technology inspired by some human cognitive abilities. It comprises loosely related tools and methods, machine learning, deep learning, cognitive computing, data science, big data. These technologies not only aim to imitate or outperform certain natural cognitive abilities, but also have as their goal allowing us to explore various domains of inquiries that would be closed to us in the absence of such tools, either for reasons of speed or because we face other types of limitation. For example, we cannot directly explore the inside of the brain without destroying it. But artificial cognitive systems such as functional MRI, allied to AI, deep learning, allow us to recreate images of its internal functioning. As with most tools, these ones are explicitly developed to do that which we would not be able to do without them. Just as an airplane or a crane allow us to fly or to lift extremely heavy objects, thanks to artificial intelligence system, we're now able to accomplish tasks in operation which were unthinkable until recently. If computers were as slow and error-prone as we are when calculating, we would not have invented them, or at least we would have. If we had done so, we would not use and rely them as we now do. It follows that in comparing human cognitive abilities and artificial intelligence, no general conclusion can be drawn, and especially that there is no universal scale on which we can compare human and artificial intelligence. Such comparisons are always local and partial. They bear on specific, often highly particular abilities. It also follows that questions as, can artificial intelligence surpass us, are not well formulated and thus are highly misleading, inasmuch as it is already evident inasmuch as it is already evident how they are to be answered. Of course, these artificial systems can do better than us. That, after all, is precisely why we have developed them, to calculate faster than us, to be able to react with greater precision to change in the environment than we do, to detect and track small variations that we ourselves are unable to perceive. Asking a question whose answer is already obvious can be misleading because it suggests that the latter sort of answer cannot be the right one, and that something else, something more momentous, must be going on. Yet, if there is anything surprising here, after all, it is certainly the extent of our own ingenuity. Such questions are not well formulated inasmuch as they suggest that we are comparing with reference to a unique scale of gradational distinction, the same property, intelligence, as manifested in two different but nevertheless equivalent bearers, namely humans and artificial systems. However, neither human nor artificial intelligence can be said to amount to coherent and unified faculty, nor is there any scale that would allow us to compare them in toto. This does not mean that there are no important and urgent questions to be asked concerning the place and role of these technologies, but whether or not society will be taken over by some superintelligence artificial entity that will enslave us or even eliminate us is definitely not one of them. Questions such as this are nothing better than the opium of the people, serving as they do to distract us from the real matter of concern. Once we abandon the fantasy of being able to measure as a whole the strength or power of artificial intelligence compared to human intelligence, more interesting forms of comparison become possible. In the remainder of this presentation, I will focus on three issues or aspects of the way intelligence is realized in humans and in many of the artificial systems which we now build. The first is embodiment. To what extent is the way in which a cognitive system is embodied relevant to what it can or cannot do? What consequences follow from different forms, from the different ways in which human and artificial system embody intelligence? The second issue is that of autonomy. What does it mean to say that an artificial system is autonomous? And is this different from what we mean when we attribute autonomy to humans? In this section, I will also touch upon the question of moral autonomy. Finally, I will address the question of judgment. In the context of philosophy, this is an issue not often raised in connection with artificial intelligence. However, it is implicit in much of the literature that concerns itself with the consequences of the proliferation of artificial cognitive system in such socially required area as the legal sphere, job candidate selection, performance evaluation, the screening of social welfare application, and so on. I argue that any deficiency or failure at the level of judgment, such as may be identified as common to different artificial systems, constitutes a philosophical issue and not merely a reflection on the narrow interest of those responsible for developing the systems in question. As we shall see, the three issues, embodiment, autonomy, and judgment, are closely related, this being for deep philosophical reasons that have little to do with the debate about mind and matter. The difference between artificial and human intelligence, to which I point, do not reveal some ultimately unsurpassable limits to man-made systems. Rather, they reflect how these systems are made, something that partially depends on what we ourselves want from them. Whether in the future we might be able to create artificial cognitive system whose form of intelligence would be closer to human intelligence is, I believe, an open question. My claim should therefore not be construed as reflecting some understanding of the definite characteristics of artificial systems per se. Instead, they seek just to illustrate some features of present-day artificial cognitive system, ones that are important and which are, I agree, also consequences stemming from our own choosing of certain forms of embodiment and of autonomy for these artificial systems. I mean, this is related to my interest in robots as opposed to artificial intelligence, classically, I must say. Embodiment. Embodiment is now a major topic and has come to define a significant new approach within cognitive science and philosophy. It first appeared as a reaction to and criticism of the view that all cognition is computation. This computational view is implicit in the original project of artificial intelligence. The idea that we can reproduce all aspects of human intelligence with the help of computer implies, firstly, that there is nothing more than computation to human intelligence, as computing is all that the computer itself can ever do. Secondly, it also implies that whether the system which carries out this computation is a human brain or an artificial system whose components are silicon chip, is a matter of little or no consequences for what it can know or come to know, or how it arrives to this. Finally, it implies, at least implicitly, that as cognitive human beings are or can be reduced to their brain as the organ that carries out computation, so that nothing else counts. Embodiment, construed as a research project, rejects these presuppositions. It argues that there is more to cognition than computation, and that we are more than our brains. The body, the material that gives shapes and makes real the cognitive system, is not like a dress or suit that the mind could change at will, but a part and parcel of the system itself. It participates in what and how the agent knows, not as something external to the mathematically, computationally defined cognitive system, but as what makes the cognitive agent what that agent is. Embodiment is thus the idea that the material and not only the computational dimension of cognitive system, be it natural or artificial, is fundamental to the way in which it knows and participates actively in such knowing. This contribution of the material level, it is argued, is the proof to the fact that there is more to knowledge than mere computation. Many artificial cognitive systems, in the sense of artificial agents that can know their environment and react autonomously to changes in these environments, are embodied in a very different way than human are. The point I wish to insist here is not so much the contrast between the silicon-based hardware of computers and the neuron-based wetware of humans. Embodiment, as I understand it, is primarily concerned with something else. The body of an agent is not simply the material stuff of which it is made. Embodiment also refers to how the agent acts in the world and communicates with others. From a philosophical point of view, this means that what this means is that rather than construing the body of the body as a prison for the soul, hiding the ladder to the world, we should rather think of it in the opposite, as corresponding to my being in every sense of this term, exposed to the world. An embodied agent is one who is in the world as an object and interacts with the world through this objectivity in a way that is exactly what it means to have a body, as opposed to being, say, a purely mathematical object. The body which we are determines how we are in the world and how we communicate with others. This applies not just to computers, but also to other artificial cognitive systems, as well as to humans and animals. An agent only interacts with the world, and in a sense, only knows it if it exists as more than a mathematical object. It is also all or part of a material system. Embodiment construed as a research project amounted to the exploration of the claim that the material realization of a system has important consequences for its cognitive capacities. We humans, like many other biological beings, are embodied as individuals. That is, we are embodied so that as distinct entities, implying different places in physical spaces, entities that cannot occupy simultaneously more than one such place. There are to some extent entities that are to some extent bound to a given place and that can only ever be in one particular space at a given time. This, I think, has important consequences for the way we know and are known by others. First, we are and show up as being independent loci of both acting per se and its initiation. The individual agent presence in the physical space is both necessary and sufficient for it to act. And where the agent is located in physical space is also where the agent acts. It may be argued that thanks to modern information technology, it is, and perhaps also to not so modern ones, such as letters, we can also act where we are not ourselves located. For example, I can give a talk in Montreal while being in Quebec City. This is sometimes true for some of us, but not for all. It is so only for those who have access to complex technical and social systems, in the absence of which such action at distance is impossible. However, none of us can avoid acting where we are. Because our knowledge as individual agent is related to our ability to act, we are immediately interested and concerned by what we know. That is to say, our knowledge of the world involves each of us individually in a particular way. For example, my knowledge of where the chair is inseparable from and colored by my goal of sitting on the chair or avoiding crashing into it. In consequence, distinct individuals, and that I think is a fundamental point, inevitably embody different point of view on the world. Where we are concerned, knowledge is necessarily, as far as we are concerned, knowledge is necessarily plural and contradictory. This basic human characteristic also plays a fundamental role in our moral life. Firstly, responsibility can only be attributed to human agents because they are individual who act individually. This is also why it makes sense to encourage them, the different people, to pursue certain courses of action and to avoid other courses of action. Secondly, the multiplicity of point of view, which this form of embodiment of intelligence necessarily generates, opens up a space for dialogue. Because as individuals, we are individually interested in the world and involved in our knowledge of it at all time. We will at times inevitably disagree and can therefore criticize each other. Furthermore, individual embodied agent can be punished, something that is impossible for an agent not individually interested in the world. Being individual thus constitutes a certain way of being in the world that is inseparable from our particular way of knowing it. Artificial intelligence, in most cases, is not embodied as individual, but rather embodied in systems, where it appears in the form of intelligent artificial agents or data-driven agents. These agents possess neither individuality nor personhood. They are analytical agents rather than material entities. An analytical agent is primarily a mathematical object. It has an environment that is made up of data that represents some aspects of the material world, and the agent responds in a more or less complex way and autonomous way to changes in that environment. The agent is part of a complex system that will usually connect together many different types of technologies, some electronic, other mechanical, some cognitive, and others social. For example, trucks and their drivers are part of the banking system. This heterogeneous system provides the artificial agent with data and is constituted in such a way that its numerical response can have consequences in the world. The algorithm or section of code that processes the data in the world with certain objective in view is considered as the agent because we attribute responsibility to it for whatever it is that relevant systems do in the world. Whether it will be selling underwear, giving direction, allowing the withdrawal of money of an ATM, or performing diagnosis. On many occasions, there will be more than one intelligent agent involved in obtaining the desired result. The agent is analytical because without the complete system of which it is part, it would not be able to do anything at all. It would not be an agent. In that sense, it is not a real agent, for it cannot act without the old system of which it is part. Unlike an individual agent that can act by itself, it is only the whole system that can bring about any transformation in the world. It follows that there is no individual object in the world that corresponds to the agent. The agent is immaterial. In such cases, which are the most frequently occurring one, artificial intelligence is not embodied as something, but embodied in something. Embodies, that is, in a system that itself is not, or to which it does not correspond, yet without which it would not exist, or at least could not actually figure in the world. In consequence, artificial agents who are analytically responsible for certain events happening in the world are invisible and radically anonymous. They are anonymous just insofar as they are not individual. To put in another way, artificial agents cannot be individualized otherwise than as mathematical objects. It does not make sense to ask who they are and where they are. Furthermore, the calculation of whatever function they determine may be distributed over many different physical space in the internet or cloud. At least three important consequences follow from this strange form of embodiment. First, when dealing with artificial intelligence, we have the impression that we are faced with some kind of omnipotent and omnipresent invisible entity over which we have little control. The truth is, however, that we are dealing with numerous and sundry material and social systems devised by various persons, enterprises, and administration for different specific purposes. For example, to sell books, to track our movement, to filter job application, for targeted advertising, to stop suspected terrorists, to control circulation, to evaluate school teachers or welfare applicants, for targeted policing, for political influencing, and so on. The extent to which we who are targeted by this system have control over this system does not depend so much on the artificial intelligence as such, in other words, how intelligent they are, as on they have been made, what their ownership developers wish to accomplish, and how much room has been left for users to respond or simply opt out. That was in the previous talk, that was very clear. All of these technical issues actually reflect the social, commercial, and/or political goals of those who adopt and promise and promote these systems. They often also bear witness to their short-sightedness or their misconception concerning AI. However, these characteristics of the system will invariably entrench and transform power relationships obtaining between users on the one hand and the dominant social agents who create them on the other. The second consequence to be noted is that unlike individually embodied agents who inevitably provide a multiplicity of different and often contradictory point of view, and analytical agents that can deal with thousands and even millions of demand, faces, applicants, or diagnoses will impose on all of them just one and uniform point of view. There may be some circumstances where such homogeneity in the response constitutes an advantage, but that is certainly not always the case. Especially when the role of the system with which the artificial agents, in which the artificial agents is central, is to reject or dismiss people or to constrain individuals' freedom. This absence of a minority report can have dramatic consequences. The unicity of point of view also limits how and what the artificial agent can learn. It can learn through reinforcement and and do better what it already does, but in the social domain, this improvement of its performance, as has been shown, often corresponds to a self-fulfilling prophecy that makes the agents even more deaf to the claim of those who contest its decision. What the system cannot learn is how to do something different while doing the same thing. What it cannot gain is a different point of view on whatever it is that it is doing. Here, it is worth noting that although this is a technical limitation of the system we are currently engaged in building, there is little basis for thinking that this is an absolute one affecting all artificial cognitive systems. The simple fact is that we do not want to have automated systems that can change their mind. Finally, invisible and immaterial analytic agents cannot be individualized, cannot and should not be held morally, and who cannot be individualized, cannot and should not be held morally or legally responsible for anything. The system of which they are part and which have consequences in the world are tools created by different persons to achieve specific goals. They are adopted and implemented by the same or by other persons for the sake of what they can or cannot do. Because employers wish to speak up to speed up their job application, for example, or think that AI will make them more objective, or because the owners of trucking companies would like to reduce the cost in the form of drivers' salaries and social benefits. Therefore, if harm comes to others because of these tools, clearly it is not the tools themselves that should be held responsible, but rather, as usually is the case, with any potentially dangerous technology, those who have decided to use them. In fact, such systems cannot be held responsible because, as was indicated earlier, they are not individually interested in or concerned by the result of their own acting in the world. As we shall now see, that is closely related to the next feature, autonomy. It may be asked, if those artificial systems, if those artificial systems were autonomous, an analytical agent appears to be but a clog in a complex system, and no matter how sophisticated it may be, it is constrained by the objective pursued by the system as a whole. Is autonomy then, however complex it may be, seems highly limited. However, what about a self-driving car that has to choose between harming a pedestrian or its passenger, or a military drone that autonomously recognizes its target, evaluates collateral damage, and decides whether or not to fire? Are these machines sufficiently intelligent and autonomous to be held morally or legally responsible for what they do? And are they not embodied differently than analytical agents? The fact is that, like intelligence, autonomy is a rather ill-defined term, and moral autonomy even more so. In robotics and artificial systems, autonomy is usually defined as the ability of the system to adapt by itself to changes in its surrounding. This entails that autonomy is never absolute. It is a relational property relative to a given environment. Thus, a tiger that is autonomous in the jungle is not autonomous in the zoo, where it cannot satisfy its basic needs, but depends on a human keeper to survive. A robotic lawnmower, which is only autonomous, for its part, is only autonomous in an environment where there is an electric grid and a station where it can recharge its battery, and where the topology of the terrain is such that it can easily circulate between grass and the recharging station. In the first case, the tiger cannot lose its autonomy when its environment artificially becomes excessively restricted. The jungle is replaced by some cage in a city zoo. In the second case, if we open up the environment, so to speak, the lawnmower appears less autonomous. It is seen to depend on some quite special man-made condition that allows it to function properly. It is only in this artificially created surrounding that the robotic lawnmower can appear to be and actually can be autonomous. This is not entirely surprising. It reflects the fact that unlike what is the case for natural systems, what it means for an artificial system to adapt to its environment is defined by the system's maker. While for a tiger to adapt means to survive and to reproduce, for a robotic lawnmower, it means to mow the grass when necessary and to go by itself, recharge its batteries at the appropriate station. An artificial system that adapts to its environment in that predetermined way acts autonomously. The domain of autonomy or environment of an artificial agent is always heterogeneously defined with a view to the task that it is supposed to accomplish. Whether it be an autonomous car, military drone, or an algorithm deciding simple cases in lower courts of law, such artificial agents will exert their autonomy in a domain that has previously been determined by their programmer or designer, who has also defined what it is for them to act adaptively. This domain is inevitably narrow and poorer than the environment in which we ourselves live, because for both technical and methodological reasons, designers can only include into the machine environment those elements necessary for the systems to accomplish the task for which it is designed. The system is simply blind to everything else. For it, those other aspects of the world simply do not exist. The autonomy of a natural system, being an expression of the way natural agents are individually embodied, is inseparable from the fact that it reflects the fact that the agent is directly concerned or interested by the consequences of its action in the world. Its autonomy is a mean to the satisfaction of its own basic need, something which is not the case with artificial agents. It is we, the designers and users, who are interested in the consequences of the artificial agent's choice, who define what it is for the artificial system to act autonomously. Unlike a naturally autonomous system, an autonomous artificial agent is not interested as an individual in the consequences of its action. It is we who care about it. The system is itself not concerned about the consequences of its action in the world, nor do we want it to be. This is why it does not make much sense to think of artificial agents as having rights. Rights, as Joseph Raz argued, are essentially based on person's need. A right corresponds to a need that is so important and central to an agent that it becomes legally entrenched and morally foundational. However, artificial agents do not have any needs that are proper to them as individual agents. They only have those which we determine are useful to them in relation to their accomplishing whatever tasks we have designed for them. That is why, appearances notwithstanding, autonomous vehicles are not individually embodied, but rather essentially just analytical agents. As Luisa Damiano and I have argued elsewhere, this is not an inevitable limitation where artificial systems are concerned. Rather, it reflects our own choice and objective as designers of these systems. We do not want to create truly autonomous artificial agents because we fear that what the later may do. We do not want robots and artificial agents that will do as they themselves think fit. We are not interested in artificial system agents that will, like human workers, criticize us, refuse to do what they are asked to do because they judge it to be morally objectionable or inappropriate to the task at hand, or simply because they feel they have done enough for today. We want artificial agents that will do what they are told, what they were designed to do. We want mechanical slaves, not morally autonomous artificial agents. We want artificial agents whose domain of autonomy is very well and precisely defined, where this rules out the possibility of their being morally autonomous. There are many, well, I want to read all of this. Yes. A morally autonomous agent is one who submits to obligations that, unlike a law of nature, unlike a law of nature, do not bind the agents, but do not determine its action. A moral obligation differs from a law of nature in that it does not necessarily bring about a certain state of affair. This is implicit in Kant's distinction between acting morally and acting in conformity with the moral law. At this point, all moral machines and ethical robots that have been designed or imagined as have been designed or imagined as programmed to act in conformity with the moral law, usually understood as some version of utilitarianism, but there are none that can act morally. Acting ethically for such a machine is to follow or to be enslaved to the ethical rules which they are programmed to obey. However, a person or an artificial agent only acts in a morally autonomous way if that agent could have acted otherwise. That is to say, if it could have acted immorally instead. This is what present-day moral machines cannot do. They must follow the moral rules that they have been programmed to respect. Finally, and this brings us to our last feature, which is judgment. A morally autonomous person is one who can recognize that another person or another agent has a legitimate claim, even in the absence of any pre-existing moral rule that justifies or ground that claim. This idea is to be found, for example, in Sand's notion of being against injustice. A morally autonomous agent is this sense, will be one who is not enclosed within the rules of existing morality, but one who does not think that all there is to morality is the satisfaction of a finite set of rules, and who, like the Good Samaritan, for example, is able to recognize that others can have legitimate claims even when these claims go against existing rules. So judgment. To put the point I have just been making in another way, a morally autonomous agent is one that can judge that a situation is unfair, unjust, illegitimate, or morally wrong, even in the absence of a rule that defines it as such. It is one that can judge that something is inappropriate or wonderful, or can judge what morally needs to be done in the absence of any prior rule or example showing what is the right thing to do. This ability to judge in the absence of a rule lies at the heart of Kant's conception of aesthetic judgment, and it is argued that it also grounds the fundamental form of moral normativity. To judge, in one sense, is to apply a rule, and this is something that artificial cognitive systems can do extremely well. But in another closely related sense, it is able to know when a rule is applicable and when it is not. This latter is something artificial systems have more difficulty doing. We need to determine the type of case to which the rule applies, and this will rest in turn on another rule. At some point, however, the regress must stop, and we must come to a point where there is no rule for how to apply another rule. So we need judgment. Therefore, judging in this sense is to some extent always done without a rule. That is to say, not necessarily in a complete absence of rules, but at least partially outside of them, even if just to determine whether the rule applies to this set of circumstances or not. Finally, while the two meanings given above both imply realizing that something counts as an instance of a pre-existing rule, to judge can also sometimes mean discovering a rule in the example. This last meaning of the term is how conceive aesthetic judgment. It corresponds to what Ferrara, for example, defines as exemplary validity. An exemplary action or work of art constitutes an exception or transgression, something that does not fall under existing rule and which becomes the guiding principle or paradigm of a new rule. It asserts itself and is recognized for its value over again, or at least outside the existing rule. In this sense, actions and decisions of exemplary quality lie at the heart of a moral and cognitive progress and discoveries. What interests me, and what I believe to be central in the context of this last meaning of the term, is the contradictory aspect of the cognitive operation involved. To judge in this sense requires one to recognize that something contradicts or falls outside the existing rules, and yet not simply discard it as meaningless or as a purely negative instance of something, but to recognize that it is meaningful nonetheless, either in itself or relative to the very rule that it contradicts. Precedent in common law sometimes plays such a role, functioning either as something that exemplifies a rule or as prompting us in an exemplary way to transform its meaning. To judge without a rule is something that today's artificial systems are unable to do. This deficiency is partially technical, being due to the way in which they learn. It is also due to the way they are embodied. The fact that they are not individually embodied and therefore cannot be morally autonomous condemns them to only ever instantiate a unique point of view, one which, because of the fact that they learn through reinforcements, they can only reassert in all circumstances. This makes it impossible for them to learn through contradiction. The human being's ability to judge is, I believe, a consequence of what Hannah called the human condition of plurality. The fact that it is not men and women, not man with a capital M, that lives on the earth and inhabit the world. In other words, it is the plurality of point of view which individually embodied morally autonomous agents bring with them that allow us to judge, to recognize they are what falls outside the rules can also be the foundation of a new rule. That its failures to fit the rules does not make it meaningless. It may, of course, be objected that humans are not very good at judging. Examples of bad judgment abound in both private and public spheres. This is certainly the case. However, as this objection itself clearly illustrates, humans do distinguish between good and bad judgment. And they are impressed by exemplary good and bad judgment, which are exemplary precisely because they give rise to new rules or norms of what should or should not be done. We may disagree with each other about what constitutes a good judgment, but language of judgment and of exemplary judgment is one in which we humans are conversant, artificial systems are not. Interestingly, contradictory judgments are at the heart of some of the most important intellectual activities human beings engage in: law, politics, science, philosophy, and theology. At the same time, in all of these areas, there has always existed a tendency towards unification, towards passing away or erasing such disagreement or contradiction and replacing them by a single and unique point of view. The central characteristic of present-day artificial intelligence suggests that it constitutes, artificial intelligence, another expression of that very same old tendency, and that it is therefore unlikely, artificial intelligence, to transcend human conditions. Thank you very much.
Thank you for this super interesting presentation. I want to ask a question about emotion. That seems to be, to me, one of the main things that separates humans from machines. And it seems like a lot of the our intelligence is used to perform actions that we think will lead to a certain emotion and a feeling, or avoid that feeling. And the same thing perhaps applies to judgments, in that we will take judgments that we believe will eventually lead to a certain feeling. So I was wondering whether you see a role for emotion in bridging the gap between human intelligence and artificial intelligence.
Thank you for that question. Yeah, I mean, the answer would be positive. Yes, I think there is a place, but I would think that emotion is essentially related, the fact that we have emotion is essentially related to the fact that we are embodied creatures. And I think this dimension of embodiment is really, really important. I mean, one of the points I'm really interested in is the fact that, I mean, the philosopher Hans Jonas has said of certain artificial systems that they are biologically indifferent, which means they are indifferent what happens to them. And this is the big characteristic about us, is that we're not indifferent to what happens to us. And this is related to the fact that we're physical structures which occupy one place in the world, and the car, I have to avoid it or else it runs me down. Artificial systems don't have any relationship with that. And that is not because they're not smart, it's because of the way they exist in the world. But I think you're right, yeah, emotion you would want a system. I think I'm interested in robots, and as far as social robotics is concerned, emotions is a central issue, right?
Thank you.
I have maybe a question. Not so much a question, but maybe a comment and maybe a question also. You'll judge, Paul. You speak about the embodiment of intelligence, and you just spoke about robot. Can you imagine a time where the robot has this ability to judge and could then maybe replace this the human being as a scapegoat? I know that you know, referring to René Girard's thesis, of course, but instead of having a scapegoat, a human scapegoat, but a robot one that could concentrate all the fears and the emotion of a human being, and then save maybe human lives and diminish violence. Is that a very far-fetched reflection?
I don't know what to think. Actually, have you ever seen the movie, what is it called? Is it iRobot? There's a movie, I can't remember exactly which one it is, but in which the robots serve the role of scapegoat to some extent. There's kind of like a park, and people throw objects to robots and destroy them. And in that sense, they serve the purpose of scapegoat. The other question, I mean, was, can we have robots which can judge, in a sense? And that's a very different issue. But I think that judgment is really related to the fact that we are dealing with a creature which is interested by its own existence in the world, and whose point of view on the world is relative, or made relative because of that. And sure, maybe in principle that will be possible, but I don't think anybody is close to making anything like that today.
No, of course not, but let's a little bit.
Because when we think about, once we start thinking about the future, then we can imagine whatever we like.
Exactly. Merci. Thank you.
Yes.